Hi, I'm Grant and welcome to the final mock exam for AGK. Today what we're going to do is we're going to answer some questions using a question bank. I'm going to follow the same format as I've done in previous mock exams and progress tests, where I pick a random selection of questions featuring all of the topics that are covered in AGK. You'll be able to see how I answer them, what sort of mistakes I make, anything that you would have done differently, and hopefully you'll get a flavour for how to best tackle these sort of questions when it comes to exam time. Okay, so here we go. This is the collection of questions that I've picked out. We've obviously done previous mock exams. If you've watched them, you know the format. I've gone through and clicked to view all the questions and quickly cycled through, picking random ones that say things like DC or AC or piston or turbine, or just sort of the keywords, to create a collection of 80 questions, because 80 questions is how many questions are in the exam, and it's probably going to take a while. So I can't remember exactly how long you get for this video. I'll put it up on a little note on the screen right now, but you've got to be quite efficient with these questions. So without further ado, let's just do it. So AGK final. Oh, there's the questions. We don't want to do that. Let's take a test. After I've answered yes. Okay, so I didn't actually read any of those questions, so I've not been cheating. Right, question 1. What is the purpose of having a vent in a fuel filler cap? To allow easy defueling, to provide suction to the fuel tank, removing excess air which could cause air bubbles. Sounds alright. To allow fast refueling without removing the cap. No, what's the point in the cap? To allow atmospheric pressure in and prevent a vacuum forming. It's number 4. We need to replace the fuel with air, otherwise all the fuel gets drawn into the engine and there's a vacuum created. Why can't I see the bottom of the screen? Which of these statements about an auto brake system during rejected takeoff is correct? Using RTO mode provides the best stopping performance during a rejected takeoff. Sounds good. An auto brake system disarms automatically when the airplane has come to a standstill after an RTO. Not necessarily. You need to sort of deactivate the auto brake normally with the toe brakes. In the RTO mode, the auto brake system provides a fixed level of deceleration. No, that's all the other modes. With RTO mode, it's just maximum brakes. When the RTO mode is armed, the system will operate at any speed when the takeoff is aborted. No, again, not necessarily. Sometimes it only operates above a certain speed. So I'm going to go 1. Cool. And yeah, as I've mentioned before in previous videos, a lot of cool features with this question bank. Comments, again, is my favourite. Just seeing what other people think helps you to figure out where you might have gone wrong if you made a mistake. And the explanations on the right, they used to be on not all of the questions. They seem to be quite consistent now on the questions. You get more of a percentage of the questions have them than don't have them, for sure. Anyway, question 3. The thrust reversers of jet engines may use clamshell doors in order to change the direction of the exhaust gas stream. Yep. Reduce the pressure of the exhaust gas stream by diffusing it into the atmosphere. No. Stop the flow. No. Absorb any surge in engine thrust. Changes the direction. It pushes it forward instead of pushes it back. There we go. The pilot may be prevented from retracting the landing gear whilst the aircraft is on the ground. There's basically a physical locking pin that goes through the landing gear selector. So by pneumatic interlock, which disables the hydraulic up selector, kind of. Doesn't have to be pneumatic though, because any attempt to select the landing gear will result in a flashing warning light and a loud horn. Probably will. By a guard on the selector switch cannot be removed until the aircraft is airborne. No. By the electrical control system being disabled by the weight on wheels switch. It's either going to be an interlock which disables the hydraulic up selector, or an electrical control system being disabled by the weight on wheel switch. Although that was the one that I was drawn to first, so I'm going to go for that. No. The electrical control system makes sense, doesn't it? If the weight is on the wheels, I suppose I even said it doesn't have to be pneumatic. So I should have listened to my own logic. By the electrical control system being disabled by the weight on wheel switch. Makes sense, doesn't it? You don't want the landing gear going up if there's any weight on it. An engine pressure ratio can be defined as the ratio of, so this is input to output. So the stuff coming in at it's not going to be the jet pipe total pressure compared to the compressor inlet total pressure. Jet pipe total pressure to combustion chamber pressure, compressor outlet to compressor inlet. That's just going to be sort of like a compressing ratio. I'm going to go for this one. Yeah, and see if... So it's basically the jet pipe is the turbine output and the compressor inlet. So it's the total from... like, what's this going to draw? Yeah, so if you got the engine like that, you're reading it here and like there, where the actual main of the combustion chamber, the compressor, the combustion chamber, and then the turbine. So all sort of the big spinny parts of the engine. That's what you're reading off with that terrible drawing that I've just done. Redundancy in systems is the duplication, triplication, that's a good word, or more of critical systems. The situation in which a catastrophic failure is caused by a single failure, no. Connecting components in series to improve performance, well, that doesn't make any sense. Two systems working together in tandem, now it's the duplication, triplication, or more. You've got 3 hydraulic systems for redundancy. Please refer to the annex. What is the position of the APU bleed valve during standard operations? Okay, what have we got here? APU bleed valve, pack heat exchanger, ECAM, bleed valve, engine start, pack 1. Wow. I suppose if you're in the air, APU's probably not going to be on. This is usually used for on the ground operations. So in that case, you wouldn't have the bleed valve open because you've got the bleed valve going from engine 1 to pack 1 and engine 2 to pack 2, and they can cross feed if they need to. You would put this on maybe if you wanted to feed both packs on the ground. I would say that in normal conditions is closed. Or auto, closed. It's got to be closed. Yeah. A very poorly written question indeed, yes, thank you. What part of standard operations do you think they mean? Start, climb, cruise. Yeah. So standard operations, I assume the cruise, but yeah, if you're on the ground and you're on the stand, it could be open. This bleed valve could be open. These bleed valves could both be closed, and then it could be supplying, with the crossfeed open, air to both packs. So yeah, fair point. Pretty poorly worded question. 8. Why does a modern transport aircraft have 2 continuous loop fire detection systems? It's so that you don't get a spurious warning. Because there is 1 loop for each of the 2 engines? No. Because both loops are interconnected to form a longer loop? No, that would still be just 1 loop. Because both loops need a detection overheat to generate a fire warning? Yes. Because 1 loop is for the... No, it's answer 3. Both of them need to be active. The term bootstrap is used to identify a cabin... The term bootstrap, when used to identify a cabin air conditioning and pressurized system, refers to the air cycle machine. It's this bit in here. So remember, we've got the air coming in, and then you've got sort of the turbine section. The compressor section comes up and then comes back out via a turbine section, and this sort of passes through another heat exchanger and then goes over there. Again, terrible drawings, but this section in here, and then you've got sort of a dehumidifier type arrangement here. You've got a first heat exchange here. This normally is a heat exchange as well, and then you've got a compressor and a turbine there. And so this section here is the bootstrap thing. So that could also be called the air cycle machine. Yep. It's the means by which pressurization is controlled, and though that would be the PAX and the outflow valve. It's the source of the air supply, that would be the bleed air, and refers to the cooling air across the intercooler heat exchanger. No, that would be called ram air, so it's the air cycle machine arrangement. In comparison to nickel cadmium batteries, God, batteries, it feels like forever ago when I was doing them. So in comparison to nickel cadmium batteries, which of the following characteristics describes lithium batteries? So lithium batteries we use because they are not heavier, they're lighter. 2, they're more prone to thermal runaway, yes. 3, they're less expensive. Are they less expensive? Hard to say. They're less sensitive to self-discharging, more flammable. I would say they're more flammable, probably less sensitive to discharge. Expensive, I'm not sure. They're certainly not heavier, so I'm going to eliminate this one and this one because they both include number 1. And then we've got 2, 4, and 5, or 2, 3, and 4. So I believe it's whether I'm unsure about the price. So, but I'm also like, what one? 3 and 5 is the difference. So if I can confirm that 3 I'm not sure about, so let's focus on 5. I think they are more flammable. You see a lot of lithium ion battery fires, but is that just because there's more of them around? Everyone's got one on their phone. Anyway, let's take a guess. I think it's going to be 2, 4, and 5. I think they are more flammable. Yes. The purpose of a restrictor valve in an aircraft hydraulic system is to restrict flow, surely. Allow full flow of hydraulic fluid in one direction and reduced flow in the other direction. That would be a, what would you call it? Like a one-way valve, I can't remember the name of it officially. Shut off the fuel flow of hydraulic into the engine compartment in case of an engine fire. That might be like a hydraulic fuse. Prevent spillage of hydraulic fluid in case of a leak. That's a hydraulic fuse. That's sort of a shut-off valve. This is a single direction, non-return valve, that's the word. Allow the flow of hydraulic fluid in one direction, but to prevent flow in the opposite direction. That's a it's confused me. Full flow and reduced flow. That's full flow and prevent flow. So restrictor, it's not a shut-off valve, what did I call it? A single direction valve? Can't remember what I called it now. Anyway, there's ones that allow it to completely flow in one direction and then not flow at all in the opposite direction. What is the name for that? Anyway, stop getting focused on that, that's not the important thing. I think it's this. Cool. Seems to be a lot of them are answered 1 so far. Interesting. The fuel cross-feed system is only used in flight for fuel transfer from one tank to another, is only used on the ground for fuel transfer from one tank to another, is only used to feed an engine from a tank in the opposite wing, allows feeding of any engine from any fuel tank. Right, so cross feed, center tanks. Okay, it's a fairly standard setup, just looks a bit weird. So it's not used to transfer fuel from one tank to the other. It's to feed one engine from the other. Is only used to feed an engine from a tank in the opposite wing. Allows feeding of any engine from any fuel tank. Is only used because you can use it on the ground for fuel transfers with some sort of external equipment. So I'm going to say 4. It allows it because it's not only used for that. Only, the sort of keywords like only or must and things like that are very definitive can always be a bit questionable. Cross-feed valve is used to rectify the fuel imbalance between wing tanks by feeding both engines from the same tank or to feed the remaining engine from both tanks. Wing balance is not an issue for helicopters. Yeah, cool. Which of the following provide compressed air for start of a gas turbine engine? So the starting of a gas turbine engine we do with the APU normally. So, and we use the air source, we use the bleed source. So 2 has to be in there. You can also have a external high pressure air. This is quite a common thing. People's APUs break and they start it from an external air supply unit, and then the air supply unit is disconnected, the aircraft pushes back from stand and it uses its other engine to start itself up. So it's going to be 1, 2, 4. Ram air inlet's not going to be enough. Cabin heating system, no. 1, 2, and 4. There we go. Which mode of operation exists in fly-by-wire systems? Fly-by-wire. Oh, that's a bit of a shit question. So this normal mode, alternate mode, direct mode, and mechanical backup that's Airbus. That's complete Airbus stuff. They call them laws: the normal law, the alternate laws, the direct laws, and the mechanical backup. That's a rubbish question. Expects you to know way more than you need to for ATPLs. When the anti-skid system is inoperative, which statement below is correct? So the anti-skid system is inoperative. Manual braking will result in a longer stopping distance on dry runways only. Remember I said only as being a keyword, like watch out for the word only because it's very restrictive. So that means on wet runways, manual braking wouldn't result in a longer distance. So it's, yeah, only is quite a good word to look out for. Manual braking will result in a longer stopping distance on wet or contaminated runways only. So you're fine on dry, but as soon as it gets wet, it takes off. And well, it doesn't take off, but the landing distance increases vastly. Manual braking will never ensure the required stopping distance. Takeoff has to be avoided. No, it'll just be longer. Manual braking can be used, however, the stopping distance is likely greater than with anti-skid in all surface conditions. That's the most inclusive. Anti-skid not working, your brakes aren't going to be as good, so therefore the stopping distance is likely to be greater. Makes sense. 16 then. During their pre-flight inspection, the pilot notices that the top of the wing is rigid in a wavy pattern near the wing root, and that many of the screw on the underside of the wing are loose, damaged, or destroyed. Which of the following could have caused this damage? So near the wing root. So are we thinking maybe we've had a situation where the wing is, say that's the wing of the aircraft. We're talking about damage to this area and the screws are loose. So maybe the wing has been sort of pushed up and down. That's affected the root. Solar radiation is not going to do that. Increased loads due to excessive manoeuvring, natural aging of the aircraft, corrosion of screw on top of the wing. Increased loads, so the wing's being pushed around up and down? That sounds right. Yes. Top surface of the wing has been put under compression at some point, yes, and the bottom have undergone tension, yeah. Cool. One of the main systems using hydraulic system is constant speed drive, electronic fuel control system, landing gear and control surfaces, yeah, and integrated drive generator. No, it's the landing gear and the control surfaces. An electrical connection from the fly-by-wire system to the left-hand aileron has become broken in flight. How can directional control be maintained? So to the left-hand aileron, through a separate identical actuator, through a second set of wires connected to the same actuator and flight computer, controllability cannot be maintained through cables and pulleys. So fly-by-wire means that there's no cables and pulleys at all. Controllability cannot be maintained. It'd be a pretty rubbish aircraft if that's what happened. One aileron breaks and the whole aircraft is uncontrollable. Through a second set of wires connected to the same actuator and flight computer. It's not really the wires that are the problem necessarily. It's probably more likely an actuator. Yes. The maximum exhaust gas temperature of a piston engine is theoretically associated with, oh god. So, I know that piston engines are my absolute weakness. I just don't ever use them. Don't fly in an aircraft with a piston engine, so I don't know anything about them. And every time I've done a study session or anything, I've always found that piston engines are a weakness. So, fuel rich means that you're going to get loads of excess fuel, which will cool down the aircraft or cool down the engine. So it's not going to be fuel rich. Cruise mixture is going to be sort of halfway between both. A mixture ratio very close to idle cutout. That would be very, very low, very lean mixture, which would make the engine quite hot. A fuel mass to air ratio of 1:15. I'm going to go for a very lean mixture. No. See, I knew that this would be my downfall. The complete combustion occurs at 15:1, which is 1:15. This ratio is sometimes referred to as the chemically correct mixture. So when you get complete combustion of all the fuel. Fair enough, what the comment's saying. The EASA publication which lays down the design specifications of small airplanes is okay. Wow. CS 23, 29, 25, 27. I have no idea. Again, if it's a piston aircraft or a small aircraft, I'm not very good at it because that's not what I'm flying and haven't flown for many years. I think there's 25 and 23. There's two of them. Oh, there's probably four of them actually, now that I think about it. Small airplane. Let's go for the smallest number. Oh, what's the actual CS certification specifications? 23 is small aircraft, 25 is large aircraft, small rotorcraft, large rotorcraft. Well, there you go. That was a pure guess. Refer to the image. The diagram shows the fuel system of a twin-engine airplane. When in flight, the crew notice a fuel imbalance with the right wing tank having more fuel than the left. After excluding the possibility of a fuel leak, what is the most appropriate action to be taken by the crew to restore the balance? So even without looking at the diagram, we talked about this in the fuel tanks. We're saying that the right tank is going to have more fuel in it. So right is going to be big and the left is going to be lower. And we've got the two engines down here and an aircraft in the middle. My drawings today are absolutely rubbish, but you get the idea. So we're going to want to switch off the tanks, the pumps in the left, open up the crossfeed so that the fuel can come from here down to here at the same time doing there, and the right fuel will slowly reduce till it gets back down to the correct level, and then we can turn these pumps back on, close this again, and we'll have left feeding left and right feeding right. So in this we've got the, it's just a fairly standard setup, nothing special. So close the crossfeed valve and switch off the right tank pumps, no. Open the jettison valve and dump excess fuel, no. Open the crossfeed valve and switch off the left tank pumps, that's what we just drew. Force the crossfeed valve to open until the fuel imbalance is corrected. Frequency wild in relation to AC generation system means the generator is wild in frequency. The frequency just goes up and down. It varies with engine speed. You don't have some sort of constant speed drive or you don't have a constant speed drive to basically provide the consistent RPM to the generator. So let's do this question with some little numbers there just to help clarify these things. So the something system on the turbofan engine passes something through the engine inlet cowl. So it's the anti-ice, passes hot air, and so anti-icing rather than de-icing, passes hot air. So it's that second option there. The part of a piston engine, goddamn, that transforms reciprocating movement into rotary motion is called the reciprocating, so up and down to rotary, is the crankshaft. Yes. The pilot of a pressurized aircraft is maintaining level flight below the maximum operating altitude. The cabin altitude is being set manually. If the cabin altitude is increased, the differential pressure will rise. So this probably requires a bit of thinking practically. So we've got our aircraft here, let's just call it the tube, maintaining level flight below the maximum operating altitude. The cabin altitude is being controlled manually. If the cabin altitude is increased, the pressure differential will be, so we've got, 30,000 feet up here. And in here, we're going to have something along the lines of like 6,000 feet. Which means that this is very low pressure and this is higher pressure. If the cabin altitude is increased, aka goes up to maybe 8,000, let's say, that means that this pressure is lower. So the differential pressure between this and this, if this is high and this is low, then this is slightly less high because we're in terms of pressure. It would still be a differential pressure, but it's going to be a lower differential pressure because we're at a higher altitude. So it's going to decrease. Yes. Any cool diagrams? What's this? One of these very confusing pressure diagrams. 26. With regard to structural stress, fatigue means structural damage due to fatigue stress is aging. Yes. Corrosion. No. Higher craft mass. No. Load. Yeah, it's probably load cycles. More often than not, parts are restricted on how many takeoffs and landings they do, because that means a cycle of being pressurized then unpressurized. Yes. The failure of an anti-skid system, we already had a question like this, so my apologies, does not increase the braking distance during rejected takeoff, provided the pilot applies maximum braking. No. Increases minimum braking distance on dry runway only, increases minimum braking on slippery runway only, at least doubles the minimum braking distance on a dry runway. Does not increase the braking distance during rejected, maximum braking. At least doubles the minimum braking distance on a dry. I'm going to go for that because it will increase the braking distance. It does on both slippery and dry for these next two. At least doubles. Doubles seems a bit... Because what if it's 1.7 times rather than 2 times, you know? But let's go for at least doubles. I don't know why doubles. Varies with aircraft, yeah. In some aircraft flight decks, devices are fitted that consist of 2 white balls and a red ball. These are used to find the correct eye reference position, helping to adapt for dark environments, minimize eye movement, minimize head movement, minimize body movement. So it's basically so your head's at the right height in the aircraft. Yeah, that's a rubbish question again. There's what it looks like. So when you're sat in the correct position, you have the red ball covering the white ball, and that means you're sat at the correct height, essentially. The purpose of an accumulator in a hydraulic system is to sort of dampen the pressure fluctuations, yes. To cool the hydraulic fluid, no. To serve as a limited alternate source of pressure, yes. If the system fails, you still want pressure for the brakes. To serve as the main pressure source, no. So we've got 1 and 3. That one. Aircraft hydraulic systems are mainly used for format angles, and this is a bit weird. Cooling and lubricating sliding and rotating components, no, that'd be oil. Absorbing shock during taxi and touchdown, so that'd be the shock absorbers. Damping power plant and fuselage vibrations, no. Controlling and actuating large and heavy surfaces, the gear, the flight controls, the rudder, all that good stuff. Assuming the initiating cause is removed, which of these statements about resetting are correct or incorrect? Right, so again, with these sort of statement ones, I quite often just like to write down the numbers because it can get a bit confusing for me. So assuming the initiating cause is removed, which of these statements is correct or incorrect? A fuse is resettable. A circuit breaker is resettable. So a fuse isn't resettable, so that's incorrect. Because if a fuse goes, think about it in your house, if a fuse goes inside a socket or a plug, you've got to basically unscrew the plug and put in a brand new fuse. Whereas a circuit breaker is the sort of thing that you would have on your electrical box in your house, and that can be reset. So we got incorrect, correct. Incorrect. Yeah, that first one there. Yes. A relay is a unit that is used to convert electrical energy into heat energy. No, that'd be like a thermocouple? Yeah. A magnetically operated switch. Yes. A device that is used to increase electrical power. Transformer, maybe. Another name for a solenoid valve. That's a magnetic switch. Yeah, cool. Resistors R1 and R2 are connected in parallel. The value of the equivalent resistance is obtained is given by the following formula. Oh my god, right. In parallel. So in series, it's when it's just RT equals, so that's series. So in parallel is this one. 1 over RT equals 1 over R1 plus 1 over R2, etc., etc. But there is a combined one. No, stick to what you've just written down. Yeah. This is the formula. That's a great explanation, thanks. 34. In a dry sump system, oh god, again, it's piston engine stuff. The something pump, right, I'm just going to fill in these answers as we go. So, 1, 2, and 3. In a dry sump system, the something pump has a something volume compared to the something pump to make sure that the engine sump remains dry. The scavenge pump has a larger volume than the pressure pump. Scavenge. The scavenge pump, the one at the bottom of the thing, of the engine, is sucking out a large volume compared to the pressure pump to make sure that the engine sump remains dry. If it was the other way around, if it was smaller volume, then you would get loads of fuel being pumped into the system and only a little bit of fuel getting sucked out. So it's got to be larger. And it's the scavenge pump. I think it's this. Scavenge larger pressure. Yes. Oh, that's a good diagram. So you've got the scavenge pump here, needs to be sucking out more than is going in. Otherwise, you would get the sump being filled up slowly as you go. The component that converts hydraulic pressure into linear motion is an actuator. Yes. So that is the good thing about AGK, is some of the questions are just really quick. In things like GNAV or performance and things like that, you get quite a lot of long-winded questions where you got to do calculations and look at a graph or something like that, get a map out, whatever, or a chart. Whereas in AGK, quite a lot of them are just sort of facts. You can sort of figure them out a lot of the time, but there's very little in the terms of getting a graph out or a calculation or anything, so it can be quite quick that you can rattle through this, and then you can spend times on the difficult questions. Cabin pressurization is maintained by regulating the bleed air supply to the cabin. No, it's more the outflow. Controlling the negative relief valve. No, that would be if pressure goes sort of the wrong way. A special blower in the accessory section of the air conditioning system, controlling the outflow valves. That's the one. Fluctuate the outflow valve, open and close, control the pressurization. Yeah. How are flight deck windscreens on large commercial air transport airplanes normally constructed? Sandwiched. It's a sandwich layer. So 2 or 3 layers separated by air to maintain the flight deck temperature at high altitude. A single sheet of toughened glass to ensure a clear view outwards. Layers of toughened glass and vinyl to aid impact resistance from bird strike. That sounds good. Flexible vinyl only to withstand differential pressures. So this would be a problem because if they're separated by air and that air is trapped, it's going to expand and retract with the pressure changes. So that'll maybe crack the glass. A single sheet of toughened glass No, you need the lamination in case that glass breaks. If you've got one sheet, it's very thin. Even if it is toughened, it could break. Layers of toughened glass, you need layers to ensure that if one of the layers of glass breaks, you've got redundancy essentially. So, and the flexible vinyl helps to withstand, absorbs things from coming through the window, if that makes sense. It sort of catches them. Aids malleability, that's the word I'm looking for. So if a bird does fly in, it's not going to shatter all the glass, it'll probably get sort of stuck and absorbed in to the glass. 38, almost halfway. Which of the following is indicated in the cockpit for the fuel system? Fuel quantity, yes. Tank sensor location, no. Tank pressure, probably not. You get temperature, pressure is not as important. Refueling valve quantity, you want to know the quantity, you want to know how much fuel you've got left. Simple. A semi-monocoque aircraft fuselage structure usually consists of, oh god, right, ribs, spars, and skin. Ribs, front spar, rear spar, frames, spar, stringers, skin, frame, stringers. Ribs, frames, skins, frames, and stringers. Oh god, right, what are the actual technical terms for these things? So ribs and spars. Ribs are like the so if you've got the aircraft, ribs would be like sort of these bits, and the spars would go in between them like that, and then you'd coat the skin over the top to create the shape of whatever kind of plane this is. Let's make it a bit more planey. Ribs, a front spar and a rear spar. Frames, spars and stringers. Are they stringers? Or are they spars? I'm going to go for the first one. No. Skin, frames and stringers. Longerons. Ribs and spars are associated with... Ah, yes, that's where I'm getting confused. So, yes, they're called frames and stringers. Frames, the round ones, stringers, and then in the wing, you've got your. That would be like a rib, and a spar would come sort of through it. If you think about this as like a side-on view, that would be your ribs that make up this shape. Yes, of course. Cool. Well, that's a good point to learn. Good point to learn. Maybe look at the structure, whole stuff a bit more, study a bit more on that. Get these terms correct in my head if I was going to sit an exam. What is the purpose of first aid portable oxygen bottles? To provide first aid oxygen. They are only used in case of a sudden loss of airplane pressurization. No, that would be the internal oxygen, which I never did a video on. Oh well, it's quite simple, the oxygen system for an aircraft. They're used by the crew in order to prevent fatigue, that'd be nice. They're used for passengers who, for physiological reasons, might require oxygen following a cabin pressure depressurization. No. They must be used if an onboard fire needs to be extinguished. Oxygen would just make the fire worse, so definitely not that one. They're only to be used in case of a sudden loss of airplane pressurization for pressurized aircraft. So no, that would be sort of the built-in oxygen systems. That's not a thing. That's going to make it worse. For physiological reasons, might require oxygen following a cabin depressurization. This is a confusing one. So first aid portable oxygen bottles are to be used in case passengers get ill and you need to sort of give them oxygen, help with their breathing. So it's definitely not to prevent fatigue, it's definitely not to fight a fire. They're only to be used in case of a sudden loss in airplane pressurization. No, that would be the built-in oxygen systems, the sort of the chemical ones. For pressurized aircraft operated at pressure altitudes of 10,000 feet and above. They are used for passengers. So they are used for passengers for physiological reasons, I suppose they might require after cabin depressurization, but it's almost just the first half of that answer. There are user capacitors who, for physiological regions, might require oxygen. That should be the answer. Done. Yeah, the option to stop oxygen with is wild. That is true. First aid, help passengers. Yeah, that's the way to remember it. What can happen if both the low pressure booster pumps in a fuel tank fail? Cavitation at high altitude, cavitation at low altitude, restriction of speed due to limited fuel flow, fuel starvation due to lack of pressure for fuel transfer. Cavitation? Oh, cavitation. What's that? When the fuel basically gets bubbles in it. Essentially, that's what cavitation is. And that's going to happen more likely at high altitude because the pressure is lower. That's what I'm going to go for. Cavitation is where the object moves through liquid too quickly and tears the liquid, creating gas bubbles in the liquid. That's what I said. It is more likely at altitude where the air pressure is not pushing down the liquid as much inside the fuel tanks. Yes. What is the concept of control surface protection by means of a pressure relief valve? Is a feature used to increase the aerodynamic lift? Nah. A pressure relief valve provides the automatic retraction of flight control surface under excessive aerodynamic loads. So this is maybe talking about flaps that are sort of extended. A pressure relief valve is used to resist the aerodynamic loads that are exerted onto a flight control surface. No is the method by which flight control surfaces can be moved with a pilot. That would be an actuator. That would be resisting the loads that are exerted. That would just be the actuator as well. It's not going to increase. That would be flaps and slats. Automatic retraction under excessive loads. Got to be. Yes. On most large airplanes, the type of low pressure fuel pump is a centrifugal piston diaphragm gear. Low pressure fuel pump is normally, I think it's a centrifugal pump. Which of the following is true with respect to heating of pitot and static sensors? So you want to heat them so that you don't get dodgy results. I never really went into it in too much detail on ice and rain protection because it's not that complicated. Both pitot and static sensing is always heated, sounds correct. Pitot tubes are always provided with a heater while static ports may also be heated. Combined pitot static tubes are always heated but static ports are never heated. Pitot and static port heating are switched on automatically when icing conditions are met. Are they always heated, or is it just, maybe it's a bit more complicated than I thought. I think actually the static ports aren't heated because the static port, if you think about we'll go into this more in instruments when I do that class, which will probably be the next one. But the static port is basically sensing the air around us, so it's going to sense that it's high pressure, low down, higher pressure and then lower pressure up here as we climb in altitude. And the static port is basically just a thing that's open to the air on the side of the aircraft like this. It's got like a little mesh over it. And if it was heated, the air would become less dense, which is going to be similar to being lower pressure up at the top here. So therefore, I think they're not heated. Pitot tubes provided heat while static may also be, I think static ports are never heated. They may be heated. Depending on the aircraft type, okay. Fair enough. What is a common operating pressure of System 3000? That's just something fact you got to learn, Fred. The FADEC, full authority. Oh, is that what the question is? Meaning the gas turbine, full authority digital engine control. Failsafe adapter, direct, failsafe adapter, failure analysis, full authority, digital engine control. Boom. Sorry, I just sort of was speaking ahead of my thoughts there, or my thoughts were going faster than my head there. Basically, I was going to read out what that means, and then turns out that is what the question is what does that even stand for? So, full authority, digital engine control. If a gas-filled fire detector becomes broken, the result will be gas-filled fire detectors. This is the fire loops or the overheat sensors. An increase in pressure, a decrease in pressure, causing a fire warning, an increase in pressure causing a fire warning. Loop fault indication. It's got to be a decrease in pressure. Surely the gas escapes. No, decrease in pressure causing a fire loop fault indication. What? Because it's not two. If it was two loops, then we'd get the fire warning. And if it's only one loop, the fault, because we need both loops to be activated to give us a fire warning. The formula to calculate the total displacement of a multi-cylinder piston engine is piston area times piston stroke, piston area times piston stroke times number of cylinders, total displacement, cylinder length times cylinder diameter. So we're going to do the piston area times the piston stroke. That's going to give us basically this volume of our piston. So that's going to be the stroke, and then it's got to be times the number of cylinders. Yeah. Done. Which of these systems about the principle of operation of a reaction axial flow turbine are correct or incorrect? Reaction axial flow. Also, a axial flow turbine is a jet engine. I hate the way they call them axial flow turbines. Reaction turbine blades cause the turbine stage to rotate by the aerodynamic action of the airstream directed to flow past the blade at a particular angle. In a reaction type axial flow turbine stage, both the blades of the stator and the rotor are acting on the aerodynamic principle of an airfoil. An airfoil. What on earth? Right, I need to read that again. Which of these statements about the principal operation of a jet engine are correct or incorrect? Reaction turbine blades cause the turbine stage to rotate by the aerodynamic action of the airstream directed to flow past the blade at a particular angle. Yes, because that's what's happening in the turbine. The air passes over it and it rotates because it interacts with the blade. Yes. In a reaction type axial flow turbine stage, both the blades of the stator and the rotor are acting on the aerodynamic principle of an airfoil. Stator and rotor. Yeah, both correct, aren't they? Incorrect for the second one. Why is the second one not correct? An airfoil might define a stream, but about the key function for the lift. Turbine blades guide the airflow into the turbine blades at the correct angle, but they're not creating lift. Yes, that's fine, they're just creating a force. The reaction blades are aerofoils, and the passage of air over them creates a force and drives them around. Apparently, that is correct. Question, answer, explanation change. Both correct, so I was right. Even though I'm wrong. So we'll give ourselves an extra point if we need it. The pilot's control input in a fly-by-wire system is linked mechanically to a computer and then to the flight control surface. Not mechanically. Converted into an electrical signal, yes, and linked via a computer to the flight control surface, yes. Linked by mechanical cables directly to the flight control surface, no, that'd be fly-by-wire. Linked by electrical wires directly to that would just be pointless, so it's got to be via a computer. Which of the following will you find in a wet sump lubrication? So no separate fuel tank. So, or not fuel tank, oil tank. So there's, well, there we go. No separate olive oil reservoir. Maybe that's what was in my head. So there's not a separate oil reservoir. So 2 is not going to be in there. So it's not going to be 1 and it's not going to be 3. We will have a integrated oil reservoir. Yes, that's 4. That's correct. A pressure pump and a scavenge pump. So what did we say? It was no separate oil reservoir. So it's 3 and 4, or 1 and 4. I think there's not a scavenge pump. Or is there? There's nothing, there's no sump to scavenge from. That's going to be my logic. So I'm going to go for 4. 1 and 4. There you go. There is a sump, I suppose. It's kind of built into the engine. In a large transport aircraft with fully powered primary flight controls, redundancy can be achieved by accurate rigging of the flight control surfaces during maintenance, duplex parallel control runs per control axis linked to the control surface actuator, which is supplied by the hydraulic system, multiple flight control computers linked to multiple actuators supplied by different sources, fixing both control columns to each other so the increased force can be exerted by both pilots for manual reversion. Fully powered redundancy can be achieved. So redundancy is not going to be this one. Not going to be this one. Duplex parallel control runs per control axis. Is that talking about control axis? I suppose pitch, roll, and yaw. Multiple flight control computers linked to multiple actuators. That is the most redundant. Yes. Which of the following parameters are monitored in a constant speed drive? Fuel flow and fuel temperature. There's no fuel going to a constant speed drive. Hydraulic pressure and quantity. Again, there's no hydraulics. There's a bit of oil. Oil temperature, oil pressure. In some aircraft, oil quantity. It's got its own self-contained oil system, if my memory serves correctly. Engine RPM and torque. That sounds more like it. No. Oil temperature and oil quantity. CST has its own dedicated oil system. Yes, thank you. But you do need to monitor it, I suppose. Okay, fair enough. Assuming cabin pressure decreases, the cabin rate of climb indicator should indicate. Right, so pressurization stuff, if they're talking about increases in climbs, etc. So the cabin pressure decreases. It doesn't say if we're climbing or not. So this is going to be 30,000 feet, and in there we've got 8,000 feet, let's say. If the cabin pressure decreases, it's going to become closer. If this is just the pressure here, ooh, probably shouldn't do that. This is the pressure and this is the pressure. The cabin pressure decreases, it means that we're basically getting closer to this outside altitude. So that means that the cabin altitude is going to go up. So the cabin rate of climb will show a rate of climb. Cabin rate of climb indicator should indicate, yes, a rate of climb. Which of these statements about structural design principles are correct? So 1 and 2. Fail-safe implies multiple load paths. Yeah. Yes. Because if it wasn't fail-safe, that would mean that if I don't know, the wing wasn't fail-safe, then it would, all the load would go through one path and it would completely break. Safe life is the preferred design technique for aircraft. Safe life. No, it's more sort of load cycles than length of time. So I'm going to go 1 and 2. 1 correct, 2 incorrect. Yes. 56. The removal of items from service at a specified time period, regardless of their condition, is called corrective maintenance, hard time maintenance, on condition maintenance, condition monitoring, regardless of their condition. So it's not on condition or condition, it's regardless of that. It's going to be set hard time. Corrective, nothing's broken necessarily, regardless of their condition, nothing's needing to be corrected. No condition, it's got to be hard time. Yeah. What instrument readings would pilot observed if the aircraft were experiencing a gradual internal leak in the hydraulic system? So a leak would be reducing the pressure. Low or irregular pressure wouldn't be increasing the pressure. High temperature or low temperature. What would you get? Get probably a low temperature? Or would it be a high temperature? I'm going to go low because all the fluid leaking out, taking its heat. No, high temperature, increase in the system. Blah, blah, blah. The source of air to pressurize the reservoir in an aircraft's hydraulic system is normally the aircraft's pneumatic system. How do de-icing rubber boots on the leading edge of a wing work? They quickly inflate when they've got ice covering them. They are electrical and automatically activated upon ice detection. They use hot air, they use high pressure air with a schedule, probably. Engine oil drips out through a port. No. Inflate, deflate, crack the ice off, allow the air to take it away. For this question, refer to the annex. The number in the annex that shows the retraction actuator is 1, 2, 3, 4. So the only one that even looks slightly like that here is 2. 4 is going to be sort of something to stop the rattling of the wheel back and forth, so the turning back and forth. That'll be the steering controls, the hydraulics, because you can tell this is the forward gear because it's folding up, and 3 is just the main landing gear spar or something. 2. What is the working principle of a gaseous fire detection system? So this is the loops. A closed loop, when heated, causes the gas inside to become a conductor and thereby triggers an alarm circuit. No. A closed tube, when heated, causes the gases inside to contract, which causes a negative pressure and thereby trigger an alarm via a pressure switch. A closed tube consists of a gas which changes its translucence when heated. Light sensors will sense such change in translucence and trigger an alarm. A closed tube, when heated, causes the gas inside to expand and trigger an alarm via a pressure switch. Does it contract? Negative pressure? I think it's this. Yes, gas expands when heated. The fan in a high bypass ratio turbojet engine produces greatest part of the thrust. Yeah, it does. None of the thrust, least part of the thrust, half of the thrust. No. It's the fan that gives you the most. This is why you get such high bypass ratio engines these days. That's why on big 777s and 787s and things like that, you've got these massive engines, because the bigger the engine, the more the thrust, basically. And the bigger the fan, the more the engine as well. Considering pressurization and air conditioning systems, which of the following elements are directly related to pressurization? Directly related to pressurization. So a pressure relief valve, an outflow valve, and a negative relief valve. Yeah, that sounds good. Heat exchanger, no. Water separator, no. Mixing valve, no. That would be air conditioning more than pressurization. Pressure controller, yes. Mixing valve, water separator, no. That's mixing valve and water separator or air conditioning. Pressure relief valve, outflow valve, yes. Heat exchanger would be in the pack, again air conditioning. So these 3 are the only ones that are 100% pressurization, whereas these answers here, each one of these contains something that is at least related to the air conditioning. Refer to the figure. Which component is located between stations 3 and 4? Between 3 and 4, we've got the engine intake, the first compressor stage, second compressor stage, combustion chamber, first turbine stage, or low pressure, high pressure, low pressure. So 3 and 4 would be high pressure compressor. There we go. On a full authority digital engine control jet engine during normal flight, the power for the FADEC sensors comes from, they normally have their own sources because you don't want them linked to anything other electrical in the system, because if that electrical system fails, then your engines will start operating weirdly. So the FADEC power sources on the engine have got their own little generator that they use essentially. Hydraulic systems, when operating normally, are pressurized by engine-driven pumps, a cistern reservoir, turbo compressor, ram air turbine, engine-driven pump. Boom. An anti-ice system prevents the formation of ice on engine inlets, wing leading edges, and pitot probes, removes ice, no, that's de-icing. Prevents the formation ice, yes. On trailing edges, no, it's more the leading edges. Removes ice, no, that's de-ice. So it's the first one. 68. In an aircraft, what is the primary function of an accumulator used for emergency purposes? To regulate cabin pressure? No. To store emergency oxygen? No, it's hydraulics. To provide temporary hydraulic power in the event of a system failure or emergency? Yes. To store excess hydraulic fluid for faster routine? No. It's the third one. What is the purpose of the X-feed valve in a pneumatic system? Cross-feed valve in a pneumatic system. So it's, okay, It connects pneumatic systems 1 and 2 together. It regulates cabin pressure in the event of a system failure. No, that would be, like the pressure relief valves in the pressurization system. To allow fuel to be transferred between the tanks in flight to balance. This is, that's what a cross-feed valve actually does. A pneumatic system has a cross-bleed valve, or sort of a isolation valve, you could call it. It connects hydraulic systems 1 and 2 together, so it connects 1 and 2 together. What do they call it? Isolation valve. Yeah, this is the 737. So basically you can open it and then you could have the bleed supplying both packs off of one engine, or you can close it and the left bleed supplies the left engine, left pack, right bleed supplies the right pack, that kind of thing. Start sequence of a large engine. The start sequence of a large turbine engine be powered using, it's like a pirate, be powered using. So this is just talking about what you can use to start it. APU, ram air turbine, or ground power unit. The APU and ram air turbine, 2 batteries or the APU generator, 2 external sources or other engines. What is that question even asking? That's a terrible question. The APU ram air turbine, APU ram, 2 batteries or the APU generator? The start sequence can be powered like electrical power, is that what it's asking? Or is it talking about powering it up? I'm going to go for electrical power. You can use batteries? No. That's an awful question. Yeah, so they're even saying it's a crap question. No idea. 71. Bleed air systems may be kept separate by using. These are normally, but maybe in abnormal operations. Oh, right, okay. So this is what I was talking about with the 737 overhead panel. Bleed air systems may be kept separate using an isolation valve. So it's 1 or 4. They are normally closed but may be open in abnormal operations. They're normally closed because you don't need the left bleed to supply the right pack. You only need the left bleed to supply the left pack. So you have something that looks a little something like this. You've got the bleed from the engines, and then you've got the pack 1 and pack 2. Normal conditions, you do this, but for some reason you might need to open up the valve here if this bleed fails for some reason, and then you can have the air going from engine 1 or the bleed air source 1 through to pack 2. So they're normally, isolation valves are normally closed, but they can be open in abnormal situations. What? These are normally bleed air isolation valves are normally opened, but may be closed in abnormal operations. Oh, it's not talking about the cross feed, cross bleed. It's just talking about valves located basically here. So before we even get to the cross feed isolation valves here to stop the bleed air source. Okay, fair enough. Refer to the figure. Under normal operating conditions, which of the following provides the primary source of DC power to the system shown above? Under normal operating conditions. Right, so the DC bus 1 and 2 are normally what DC stuff is powered from. So that would be the answer. DC bus 1 and 2? The emergency, which is the primary source of DC power in the system above? The DC bus bar? The 3 TRUs? Oh, because they're providing, right, okay. Yeah, fair enough. This might be quite close actually. I've had a few questions go wrong. During a walk around inspection, a yellow-brown coloured fluid is found underneath the engine. This might be the oils. Oil. So fuel is kind of clear, hydraulic pump clear, integrated drive generator is I think it's 1, maybe 2, because it's got oil as well. Yes. You need to load some cargo into a large airplane that is currently shut down. How will you open the cargo compartment door? Attempt to open it manually by prying open with a crowbar. Use the control panel to open it hydraulically. Use the control panel to open it electrically via the hand pump. That's a weird question. That's very aircraft specific. Pilots should check the wheels and tires during their pre-flight check. Which statement is correct? 2, 1. Tread separation is easily detected by visual inspection. Small bulb or tread separation is acceptable as long. No, you don't want anything wrong with the tires. Tread separation is easily detected by visual inspection. Yeah, I suppose it's fairly easy to see. Correct, incorrect. Incorrect. Tread separation quite hard to see, is it? Yeah, you'd never notice that. What? How far separated are we talking? I'm not doing very well at the end of this one. Complete the following sentence. The landing gear is typically something receiving most of the power from the something. It's typically passive. You don't normally have it receiving most of the power from the engine-driven pump. Active. Oh, because it's actively held up. Damn. A jet transport aircraft in the cruise encounters moderate to severe turbulence. The pilots forget to switch the engine igniters on as per the checklist. Which of the following is a possible problem that may arise from this condition? The engine may experience severe damage due to the turbulence. The engines will only be able to run at lower thrust settings, which could lead to low speed situation. Unburnt fuel may ignite in the tailpipe and cause an overheat. The compressor might stall or surge, leading to a flame out. The air going into the engine can be sort of inconsistent, so you want to help it along and put the igniters on. A complex aircraft has 4 independent AC generators: generator 1, generator 2, APU, and emergency. How are the generators connected to a split bus bar system? So it varies depending on the type of generator installed, with 2 or more generators in series. So you don't want to do them in series, because then you'd have to get their frequencies exactly to the millisecond lined up. So it's got to be in parallel, with 1 generator time supplying individual part of the split bus bar. In parallel with all 4 generators connected to the same part, no. I'm going to go for answer number 1. A TRU converts AC to DC. Yeah. A wild AC into fixed AC, low voltage to DC. That's a transformer, and that is a inverter. For this question, use annex if at takeoff power and full rich mixture piston engines. The mixture control is slowly moved towards lean, and as a result, the RPM of piston engine with a fixed pitch propeller increases. Indicate the corresponding area in the annex. Mixture ratio. Okay, so mixture ratio is going from full rich, slowly move towards lean, and as a result, the RPM of the piston engine increases. So it's going from this way, and the RPM increases. I think if the RPM increases, we're getting more power. But which one is it talking about? 0.2 to 0.3, 0.1 to 0.4, 0.1 to 2, 0.3 to 4. I thought we were making it more lean. Oh, we are. Mixture. Yeah, okay, sorry. 1 to 2. Oh! So the graph shows here very exaggerated. 0.1 achieved by 0.2. Yeah, so my logic there was if you got more RPM, you got more power. So I wanted to go up the way rather than down the way. If that makes sense, I wanted to go up rather than going down. And I read this wrong. Mixture ratio, obviously 1 to 10 is richer than 1 to 16 of a ratio, so you've got to be careful with the way the graphs are drawn. So finish, I reckon I'm probably about 80% 84. There you go. See all questions and answers. There was also that one that the answer was wrong to. So quick review. Yeah, felt bad towards the end. Pilot may be prevented from retracting yet another electrical versus the weight on wheel switch. It's not a pneumatic interlock. It's because then if you didn't have any pneumatic power, it might come undone, and you might be able to select the landing gear up with the aircraft off or something like that. 19, the maximum exhaust gas temperatures at the chemically perfect ratio, which is 1 to 15. Again, just piston engines, well, just never really been good at them. Rib spars and skin are for the wings, whereas skin, frames and stringers are for the fuselage. That was a key point from that. Which of the following is true with respect to heating? They can be heated. Some aircraft will have them heated, some aircraft will have them not heated. They don't always have to be heated. 47. A decrease in pressure causing a fault loop. Oh yeah, this is because you need both of the systems, both of the loops to be broken to get the fire warning. If you get just one, then it's called loop fault indication. That's 47. 49. Which about the statements about the... so this is the one that the answer in the explanation said it was actually right. So this is the actual correct answer. So we'll ignore that. 53, which of the following parameters are monitored by a constant speed drive? The internal system oil, so not the oil system that is related to the engine oil. This is the independent oil system. 57, gradual internal leak. You get higher temperatures because there's not enough hydraulic fluid to sort of cool things down. 7, I don't even know what that question is asking, so I'm not going to bother with that. Bleed air systems may be kept separate using isolation valves, yep, and they're normally open but they're closed. I think that question is very confusing. They're kept separate from each other or just separate from the system? Yeah, this one, the TRUs are the ones that are actually supplying power to all these DC buses, not just the DC bus bar. Again, wording questions. 75, the pilot should check the wheels. Which statement is correct? Tread separation is easily detected. It depends how much. In this example, yes, you're easily going to detect that, but in lower examples of tread separation, you're not going to be able to notice it. And last one I got wrong. The landing gear is typically, it is active, I suppose. It's active hydraulics because it's kept up using hydraulic pressure, and then if the pressure is released, it falls. And it's from the engine driven pump. So it's, but I was thinking normally passive as in it's normally stored within the aircraft, so therefore it's not being used. But there you go. 84%, quite good. An hour and 7. Average time per question was about a minute. I think you've got a bit more time than that in the exam, so please do take your time with this stuff. And good luck with studying, and I'll see you soon for some instrumentation classes.